Welcome back to Topic 10 for Algebra 1, Solve and Graph Absolute Value Inequalities. In Part 1, we're going to learn what an absolute value inequality is, as well as solve a few simple examples. So let's recall back to Topic 9 when we originally learned about absolute value equations. So if we have the absolute value of x equals 3, this means that the distance from our number to 0 is 3 units. So in other words, our number could be either 3 or negative 3. Because if we look at our number line, the distance from 0 to 3 is 3 units, and the distance from 0 to negative 3 is also 3 units. So what about if we introduce inequalities now instead of an equal sign? So what if, for example, we have the absolute value of x is less than 3? Well, this actually means that x is closer than or less than 3 units from 0. Now remember, with inequalities, what we would do is we would shade all of our possible solutions. That would be the shading on the graph. So with absolute value inequalities, we can also shade on the graph. If we look at our example, this is the absolute value of x is less than 3. Since this does not have a bar underneath, or it's not or equal to, this means we are going to have open circles at negative 3 and 3. Now, I'm going to shade in the middle here because when I'm thinking about the distance, I'm thinking about the distance from 0. So for example, if I have 0 to a number, let's say negative 2.9, the distance from 0 to negative 2.9 is 2.9 units. That is less than 3 units. I could also go the other direction, 0 to positive 2.9 or positive 1.4 or something, and that distance is also less than 3 units. So I can actually rewrite this as negative 3 is less than x, which is less than positive 3. My x, or my shaded values, are lying in between negative 3 and positive 3. And since I just have a less than sign here, that means I'm going to have my open circles. Now conversely, if we want to do the other part of that, we can have the absolute value of x is greater than 3. This means that x is farther than or greater than 3 units from 0. So I'm going to show this on my graph again, my number line. Again, since this is greater than 3, we're going to have an open circle. But this time, I'm going to shade away in opposite directions. Because when I'm thinking about the distance from 0 to my number, it's going to be more than 3 units. Let's say I chose negative 4. That would be 4 units, which would be greater than 3 units. We can do the same thing on the other side if we chose something like positive 5. That's also greater than 3 units from 0. We could rewrite this as a compound inequality as x is less than negative 3 or x is greater than positive 3. Now, in terms of writing a key, in order to recognize this when we're dealing with examples or problems, whenever we have the absolute value of x is less than or equal to, we're going to shade in the center. Because this is an and compound inequality. Whenever we have greater than or equal to, we're going to shade two tails in opposite directions. Because this is an or compound inequality. Something that I like to do to help me figure out the difference between the two, whenever I see less than, kind of sounds like it has the word and in it. So that's how we know that when I deal with a less than or equal to, I'm dealing with an and compound inequality. Whenever I'm dealing with a greater than or equal to, greater, that's an or compound inequality. So those little phonetics can hopefully kind of help out. Now let's move into some examples. So if we're asked to solve a graph, let's say we have the example, the absolute value of x plus 2 is greater than or equal to 1. So our first goal here, just like in equations, we'd want to isolate the variable. Here we want to isolate the absolute value. So I'll put it in absolute value signs here so you can actually see it. So that's the only thing that should be on the left-hand side. We should have no stragglers. Once we have isolated the absolute value, then we can split to get two inequalities. So in our example here, the absolute value of x plus 2 is greater than or equal to 1. My absolute value is already isolated on the left-hand side. I don't have anything outside of the absolute value that's kind of like tagging along. So from this point, I can split. From this point, I can also decide where to shade. Just by looking at the inequality sign. So once my absolute value is isolated, I can look at my inequality sign. Here we have greater than or equal to, greater or. So it's an or compound inequality, so I'm going to shade the tails eventually. Moving on to just solving now, we can rewrite this as two inequalities. We have x plus 2 is greater than or equal to 1. Again, notice how I dropped my absolute value signs once I'm splitting. And just like when we did with absolute value equations, we would have the negative option available as well. So x plus 2 is, but instead of greater than or equal to, we're also going to change the sign of the inequality and the number. So is less than or equal to -1. So here, again, there's two things you need to change: the number sign and my inequality sign. So now I can isolate x just like I would do in a one-step inequality. I'm going to subtract 2 from both sides. And what I do on one inequality, it's the same process in the other. So if you want to kind of quicken up the pace, -2 plus 2, that cancels and adds to 0. So we're just left with x is greater than or equal to 1 minus 2 is -1. And x is less than or equal to -1 minus 2 is -3. And again, this is an or compound inequality based on what we identified beforehand. Now I can graph this. Let's say I have -3 and -1. And these are both going to be closed circles because of my inequality. And I already know where to shade because I determined it right up here, tails. So I'm going to shade in opposite directions. Perfect. Let's move on to our next example. The absolute value of 1/3 y plus 5 is less than 9. So again, I want to make sure my absolute value is isolated here, which it is. So then I can look at my inequality sign, which is a less than, less than, less and. So I'm going to shade ultimately in the center. Now I can split and get my two inequalities. So I have 1/3 y plus 5 is less than 9. And 1/3 y plus 5 is greater than -9. So again, I have to change my inequality and the sign of the number. Here we have a two-step equation. So I'm going to subtract 5 from both sides, get rid of that third wheel in the relationship. 5 minus 5 gives you 0, and we're left with 1/3 y is less than 9 minus 5, or 4. And 1/3 y is greater than negative 9 minus 5, which is negative 14. Next step, because I see division here, I'm going to multiply by the reciprocal. So the reciprocal of 1/3 is 3/1. Now on the left side, it reduces and we're just with y is less than 4 times 3, which is 12. Here it also reduces and we get y is greater than negative 14 times 3, which is negative 42. Now you can multiply both sides by that 3 because you see division, which is a fraction, or if you do notice that this is really 1/3 times y and you want to divide both sides by 1/3, dividing by a fraction is the same thing as multiplying by its reciprocal, which would be 3/1. So it saves you a step if you would like. We already noticed that this is an and from before, so we can actually write and compound inequalities another way. My smallest number is negative 42 is less than y, which is less than 12. So here I have the smushed form of my compound inequality. And now I'm going to mark it on my number line. Oops. Since this is just strictly less than, I'm going to have open circles, and it already says center right here, so I'm going to shade in between. And that was part 1 of topic 10 for Algebra 1 on solving and graphing absolute value inequalities. Thanks for watching.